Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so you all are doing really great. So student, in this video we are going to learn about the capacitors. Capacitors are also called condensers that you can see here. So what we are going to do, we are going to understand what is the parallel plate capacitor, its derivation. With a complete dielectric, that means when the dielectric is completely filled between the plates, and when in second case when the dielectric is the partially filled between the plates. Okay students, so let's start the video and let's learn this very easy topic, capacitor. Okay, so as the name is there, capacitor or a condenser. So see here, a capacitor is a device which is used to store electric charge or potential energy. Again I am telling electric charge and potential energy. After that, it is made up of two isolated conductors carrying equal and opposite charges placed at a small distance. Okay, so actually this is the, here we have written from the capacitor. When we are going to learn all the things, like first we will learn one conductor will be there, then to increase the capacity we will take another conductor, then second conductor we will connect to the earth. Okay, so all these things actually whatever we are going to learn here, it is just written in a summary form. Okay, now students, you can see the space between the conductors may be air or an insulating material of dielectric constant K. Okay, dielectric constant K means what happens that in our 12th syllabus, if in case it is air or vacuum, dielectric constant or relative permittivity will be 1. If in case any dielectric material, in that situation it will be K greater than 1. If in case conductor, K will be how much? Infinite. And again I am telling this dielectric constant is also called what? Relative permittivity. Okay students, great. Now you can see capacitor is represented as, so see here, the symbol of capacitor is like this. We can write like this here, no? This is also the capacitor symbol, or we can write like this also, see, like this. And this one we used to turn somewhat here. Okay, and if we talk about here which one is the more popular, we used to draw this one here. Okay, so here we have written the two symbols of capacitor, and here yellow one is the more popular. Na? This line is straight and this line is somewhat curved. Okay students, so I hope so you have got the just the basic idea. Okay, now see here, capacitance of a conductor. Let's see now, when charge capital Q is given to a conductor, it spreads over the outer surface of the conductor. Because you know very well, na, conductor always carries charge where? On the surface, and the surface of the conductor behaves as a equipotential surface. Okay, so that only written. Next one, the whole conductor comes to the same potential V, as I have told you, equipotential, and this potential V is directly proportional to the charge Q. Okay, so students, what I am telling here, let's take here I have taken one conductor, any shape. Okay, and whether the conductor is hollow or solid does not matter, because anyhow charge will be where? The charge will be on the surface. Okay, so here I have given some charge to the conductor. You know very well, uniform conductor means like a sphere, charge will be uniformly distributed. Irregular shape conductor, charge will be non-uniformly distributed. Wherever sharp corners there, more surface charge density will be there, that we have learnt in a last video. Okay, so what is happening that here, let's take here charge how much? Q on the surface, and due to this charge what will be there? This conductor will have some potential, and what will happen that here, the conductor surface will behave as a which one? Equipotential, and electric field lines will be due to radially outward, and remember that here this electric field lines will be perpendicular to equipotential surface. Okay, but what we know that here, normally what happens that here students, this Q, the charge is directly proportional to the potential of the conductor. More charge, more potential. Okay, now after that, when we will remove this proportional sign, so one proportionality constant will come C, and here V. So what is C students? That is the proportionality constant, and this C is only called what? This C is only called capacitance of the conductor. Okay, this is the only called the capacitance. Okay, so what is the C? C is the proportionality constant. Like I know Ohm's law, resistance is there. Later you will see na inductance is there. Okay, so just like that. See here, please here, I will tell you one thing here. If I talk about here the resistance, R equal to V by I. Similarly, capacitance, C equal to Q by V. Similarly, if I talk about the L will be how much? Phi by I. Now, even you can write N also for number of turns. So here what we have to understand that whether this resistance is there independent of voltage and current, this capacitance is there independent of charge and potential, or even self-inductance is there, that is the independent of flux and current. Okay, then on which factors they are depend? They depends upon the coil. Now, what is the shape and size of the coil, what is the orientation and all that, number of things are there. Okay, but from all these things it will be independent. So here what we can tell, this capacitance if I write here, C equal to Q by V. So this capacitance is going to be independent from the charge and potential. Okay, great. See here please, as I have told you, where C is constant of proportionality and is called the capacitance of the conductor. Okay, now next one, some important points related to the capacitance. So see, SI unit of the capacitance, you know C equal to Q by V. What we know? We know C equal to Q by V. Okay, so from here what we can write here? From here we can write Q means coulomb and V means voltage. So we can tell here coulomb per volt. What is there? Coulomb per volt. Or we can write here one more unit is there, farad. F-A-R-A-D, farad, or we can just write capital F. But remember that one thing, this farad is the unit that is used to be the very larger unit. But in our electrostatics, we use some smaller units. Now, let's take for example here. If I talk about millifarad, so 1 millifarad, how many farad? 10 to the power minus 3 farad. Similarly, if I talk about here microfarad, how much here? 10 to the power minus 6 farad. Okay, next one. If I talk about here NF means what? Nanofarad. And here it will be how much here? 10 to the power minus 9 farad. And one more unit used to become, that is called the picofarad. How much here? Yes, guess. 10 to the power minus 12 farad. Okay. In all of them, which unit is the more common? The most common. So this microfarad, this unit is the most common. Others, they may ask, but maximum to maximum capacitance they used to give in a which unit? Microfarad. And please remember that how much? 10 to the power minus 6 farad. Okay. Now next one we can see. As I have told you, see, capacitance C does not depend on the charge and potential of the conductors. As I have told you, C equal to Q by V. Similarly, R equal to V by I, L equal to phi by I. Na? So similarly in this way. Now, it also does not depend on the nature of material and the thickness of the conductors here. Okay, so independent of the charge, potential, even the nature of material of the conductor and thickness also does not depend. Capacitance does not depend. Okay, remember that here. Maybe in a MCQ, AR and all they used to ask here. Now, next one is students, see, third one. Now, on which things this capacitance depends? Now, so see here, this capacitance C depends on the shape and size of the conductors is there. Okay, shape and size of the conductor. Don't be confused here. Here what is given here does not depend upon the nature of material and thickness, does not depend. But on which factors it depends? It depends upon shape and size of the conductor. Okay, it also depends on their relative separation. Like in case of parallel plate capacitor, you will see small d, small d, distance between the plates and the intervening medium between them, because between the plates we may take vacuum, we may take some other dielectric material and all that. Okay, great. Now fourth one, dimensional formula of capacitance. Dimensional formula of the capacitance. So here we have to write that. How to get the dimensional formula? See, we know C equal to Q by V. And what is V? V means W by Q. That means we can write here Q square by W. Okay, because normally we don't used to remember the dimensional formula. So here if I write for the capacitance, Q means charge, AT, square means A square T square. Okay, W means work. That means how much? M L square T power minus 2. So students, when you will simplify this, what this will come here? See, M power minus 1, because M will go up. Okay, L power minus 2, and what will happen that here? T power 4 and A square. Okay, I hope so we have done very correct calculation. So here the dimensional formula of the capacitance is what? This thing, no need to remember that. Even if you remember also, very nice. Don't remember means you can drive, no problem is there. Okay, great. Next one, students, see the principle of a capacitor. Because normally what happens that this capacitance concept, first it was coming from a single conductor, but later what happened that by doing some orientation and keeping some other plates and all that, we can increase the capacitance of the conductor. Na? So that we are going to learn principle of the conductor. Okay, so see, it is based on the fact that capacitance can be increased by reducing the potential, keeping the charge constant. Again I am telling you, because C equal to Q by V. By keeping the charge constant, if we are reducing the potential, then capacitance can be increased. Okay, and see, consider a conducting plate capital M, which is given a charge capital Q, such that its potential rises to V, and mathematically we are going to see. So here we have taken one conductor, and what we'll do? We will give to the charge to this conductor. So we know very well, as electric field inside the conductor is 0. So what will happen that the charge will come on the surface both the sides. And this is which plate, students? This is the plate M. Plate M. Okay. So let's take how much charge is there. The charge is given Q and its potential is V. So in this situation, this capacitance C is given by Q by V. Okay. How many conductors? A single conductor. Okay, now let's see here please. Now what we are going to do, we are going to increase the capacitance of the conductor. How will we do? Let's see here. Let us place another identical conducting plate N parallel to it such that charge is induced on plate N. Okay, now if V minus is the potential at M due to induced negative charge on N, and V plus is the potential at M due to induced positive charge on N, then mathematically how much here? Okay, so what I am going to do here, see, this is plate M, this is plate N. Now what is there, students? See, it was having some charge like this, it was having some charge was there. Okay, it was having some charge was there. Now how much charge was there? Q charge was there. Okay, and its potential was how much here? Its potential was V. Now what we have done? We have taken another plate N. Now, so what will happen here? This plate N is anyhow neutral. So this positive charge, what it will do? It will attract which charge? Opposite charge. That means here what will happen here? This is minus will come here. Here what will come? Minus will come. And away what will go here? Here plus will come. Okay. So only we have written that here. What will happen that, students, here? Here minus charge induced, here plus charge induced. Microscopically what will happen that here? Because of the presence of this positive charge, electrons will flow from right side to the left side. So due to the moving of the electrons, one side negative, one side positive, that is the induced. Now you tell me one thing here. Which charge is near to the plate M? Negative or positive? Just here please. Negative or positive? See, this negative charge is close here. See, even if I write here, see, this distance is D1 and positive charge distance is D2. So you can see very well, the negative charge is very close compared to the positive charge. That means what will happen that, you know very well, the potential is always inversely proportional to the distance. So whatever is nearby, that potential will be somewhat more. Okay. So what will happen that here, if I talk about the capacitance of M, C dash. So what this will come here? Charge same only Q, its potential V, due to negative charge, potential how much? V minus. Due to positive charge, this positive charge, potential how much? V plus. But you tell me please, which potential will be more? No? Which potential will be more? V minus will be more. Why? Because negative charge is close to M. Okay. Even I can tell by the number wise also. See please here. If I just for the example I am telling you, let's take here, this V value is 10. How much V value? 10. Then we can understand very well. Now what will happen that here? See, again, this V value is 10 and see, which potential is more? This V minus, because nearby. Let's take this V minus is 9 and this V plus is 8. Magnitude, I am just writing magnitude. So what will happen that here, students? See, V minus is more somewhat. Why? Because negative charge is close to the plate M. So if you will solve here, how much it will come here? By the number wise even, Q by 10 minus 9 plus 8. What will come here? 10 plus 8, 18. 18 minus 9, 9 here. So Q by 9 is coming. So here please here. Here how much here? Here Q by 10. And here how much? Q by 9. So what happened? The denominator is decreased, that means what will happen? This capacitance will somewhat increase. We can tell C dash is greater than C. Now again I am telling this negative charge is the close to M compared to positive. That's why I have given the number just 9 and 8. Now after, let's see, capacitance is increased, but still we can decrease the potential somewhat more. How we can do it? See here please. So see here please, as we have done, as V dash is less than V. What is V dash? When I will write here, na, this one here, this Q by V dash we can write here. What we can write here? We can write Q by V dash, actually this thing we have written V dash. So only see, as V dash is less than V, capacitance of the conductor increases because inversely proportional to the potential. After that, see further, if N is earthed from the outer side, then V double dash less than V dash and capacitance of the charge conductor increases appreciably. Now what will happen, dear students? See, again I am telling you, see, this is the plate M, this is the plate N, okay? And now what we are going to do? We are going to do the earthing, but first you put here the charge here, okay? Charge is there, okay? Here charge Q is there and potential V is there, and here some minus charge was there, okay? Minus charge was there, and here what we will do here? This side we will connect to the ground. So the moment we will connect to the ground, what will happen? That here some electrons, microscopically what will happen? Some electrons will come from the ground and they will neutralize this positive charge, okay? And because of that, what will happen? Due to the positive charge, potential will become 0. That means we can write here now the capacitance C double dash will become here Q by V minus here, okay? Even if I write by the number wise, Q, let's take V, how much was there? 10. V minus how much there number wise? 9. That how much coming now? Let's say Q by 1. This is just for the basic understanding purpose. Now you can see what here? Before the Q by 9, now how much? Q by 1. That means we can tell now C double dash is greater than C dash. Okay. So here what has happened that the moment we have connected this plate N to the ground, the capacitance is increases appreciably. Understood very well? Correct? First we have taken one conductor. Okay. To increase the capacitance, we have taken how many conductors? Two conductors, M and N. Now, and because of the induced charge, the capacitance is increased somewhat because negative charge was close compared to the positive charge. Now, again, we have got one more thing. How to increase the capacitance more? For that, what we have done? This plate N we have connected to the ground. Okay. And because of that, what happened? You can see the capacitance is increased further. Okay. Now, what will happen that here? This negative charge will attract all the positive charges. So, what will happen that? Here what will happen on the plate, this side will be full positive, that we are going to see next one. But I hope so principle you have understood very well. Okay, great. Now students, see, now we are coming to the parallel plate capacitor. Now this derivation is a very important and question used to come in exam also. So see here, it consists of two metallic plates M and N, each of area A at a separation D. Plate M is positively charged here. See here please, this will be plate M and this will be plate N. Now, so plate M is positively charged and plate N is earthed, that we have done before. Now see, if K is the dielectric constant of the material medium and E is the electric field that exists between two plates, then potential difference V between the plates is given by. Okay students, so here what we are telling here, plate area A, separation between the plates is the D, dielectric constant between the plate is K, okay, and how many plates are there? Two plates are there, okay. So here what will happen that here students, see, here what will happen here, some minus charge will come here. Minus charge is there, anyhow this is connected to the ground. Here what will come? As I have told you, here which charge will come? Plus charge will come. Let's take here sigma, and here what is there? Minus sigma. And between the plates what is there? This dielectric is there, this dielectric constant how much? K, completely filled, okay. And students, tell me please here potential how much? Here potential is V, and when it is connected to the ground, here potential how much? 0, okay. So students, here first what we are going to do, you know very well, we know E equal to V by D, okay. And here please, if I take here between the plates, here electric field is here how much here? E. This electric field will be how much here? First thing if I write here the electric field, okay. So this electric field will be how much here? Due to positive charge, electric field this side, let's take E plus. And due to negative charge also, electric field this side here, how much? E minus. So E plus, E minus both are which side? This side. That means electric field will add up. So I can write as E plus E minus. E plus how much? Sigma by 2 epsilon naught K. Okay. All this we have learned in previous lecture. Again, sigma by 2 epsilon naught K as the direction is correct. Direction is correct. Now, then after that, no need to use minus sign and all that. So, what this will become here? This will become here sigma by epsilon naught K. This is the electric field between the plates. Okay. Next one, see. We know E equal to V by D. So, V how much? V how much? V equal to ED. No? Now, right here. V. And here ED, that means here, please students, 1 by epsilon naught A. Sigma value how much? Sigma value Q by A. A is the area of the plate, and what is D? D is the distance between the plates. Okay. So what I have written here? E value I have written sigma by epsilon naught, and sigma how much here? Q by A. And here how much here? Into D. I hope so. Very clear? No? So students, if I write here the next one, if you write Q by V, charge by potential. So Q by V, correct? No? 1 minute here, students, something we have done mistake here. No? Epsilon not K, mistake happened somewhat here. See here, I have done mistake. Now itself we have got it here. Okay, epsilon not K. So Q by V will be how much here? If you see this one only this one here. So Q by V will come how much here? K epsilon not A by D. That means we can write here Q by V means capacitance. Capacitance is given by what? K epsilon naught A by D. Now, see, I have written in a bracket. I have written in a bracket this one here. This is the capacitance formula when the dielectric is the completely filled. What is that? C equal to K epsilon naught A by D. First, we have calculated electric field. Then, with the help of potential, we have just got this. Okay, good. Next one, see, students. If the medium between the plates is vacuum or air, that means complete, between the plates, complete vacuum or air, then what will happen that here? See, students, for the air, what will happen that? Remember that here, for the air, this K will be 1. Okay, so what I am telling you, we know C equal to what? K epsilon naught A by D, that we know. But what will happen that here? The moment I will put the value of K1 epsilon naught A by D, then C will become how much here? The C will become C naught. C will become how much here? C naught. That means what is the value of the C naught? C naught is, students, epsilon naught A by D. This is what? When between the plates, what is there? Only air or vacuum is there. So students, as of now, if I write here, see, we know C equal to K epsilon naught A by D, and here C, and K, what is epsilon naught A by D? C naught. That means we can write here C equal to Kc naught. And please make sure that this formula is valid only when the dielectric is completely filled between plates. When dielectric is completely filled. Otherwise, this formula will fail. Dielectric is completely filled between plates. Between plates. Which plates? Plates M and N. Okay, great. This thing. Because here number of confusion used to come. Now here please see. Electrostatic pressure on each plate. Electrostatic pressure, that means force by area. Come to this here. Now, so students, you know very well, opposite charges will attract or repel. Opposite charges will always attract. So what will happen that here? This plate will have one force in this direction. Now, I can tell here, this is the force F. And from the Newton's second law, this one will also attract here. And this force also how much here? F. Okay. So what will happen? Some attraction will be there between the plates. So this force, what I have written here, F and F. F and F. We can tell one thing. This plate M is placed in the electric field of N. First, we are going to focus on M. So what I am telling? Plate M is placed in the electric field of N. Okay. So what will happen that here? This F, what we can write here? Again, I am telling at this point. At this point, let's take, I have taken the point A. Okay. A already we have taken. Now let's take anything. I have taken point P here at this point P. So you know very well at point P, due to plate minus, electric field is which direction? This is the electric field direction. What we can write here? E minus, na? Towards here. And how much charge is there? As the surface charge density is sigma, but here how much charge is there? Q. We can tell, okay, here plus Q, here how much? Minus Q. Then what will happen at students here if we have to calculate this electrostatic pressure? So first we'll calculate the force. Now force on the plate M is given by here charge Q into electric field due to negative charge. So Q here, and electric field due to negative charge, how much students here please? Sigma by 2 epsilon naught K. Okay, how much there? Sigma by 2 epsilon naught K. Now students here please, this is Q and here 2 epsilon naught K, and sigma how much? Sigma is students given by here. No, sigma how much we can write here? Sigma we can write here Q by A, or we can do one thing here. Instead of converting the sigma now, we will just convert here this thing here. This thing, what will convert here? See, this Q is there now, this Q we can write here students. You know sigma equal to Q by A. So Q how much here? Sigma A. What is Q? Q is sigma into A, and here what will become here? See students, sigma by 2 epsilon naught K. Okay, so now what we can write here? See students here, see here, from this this force is given here. Force is how much here? A into sigma square by 2 epsilon naught K. What we'll do here? We will multiply with the epsilon naught K. We will divide with the epsilon naught K. Then students, it will become here, see, F equal to A. Okay, and here students, see, it will become here. Here we are going to write here, see, sigma by 2 epsilon naught K whole square. Okay, and what we see, this all these things we have taken here. See, sigma, epsilon naught K we have taken here, and here what is coming here? Epsilon naught K. So students, if I write here the resultant force, so resultant force will come what here? F equal to half. No? This half will be there. 1 minute here. See, here 2 is there, and here no 2. No, this is no 2. No, okay. No. So what will I write here? Half. And here what is this? This is the electric field here. So half, and here see epsilon naught K, and the resultant electric field between the plate how much here? E square. Resultant electric field. So force is coming how much here? Half epsilon naught K E square into A. What is this? This is the force. Okay, but now what we have to calculate? We have to calculate the pressure. Okay, so for the pressure students, what we do here? For the pressure, I will just write here. The pressure is given by force by area. How much this is? Force by area. Then we'll take this side here. So what this will become here? Half epsilon naught K into E square. What is this? This is the electrostatic pressure. Even this is called what? Energy density also. Okay students, so I hope so this is very clear. Now students, here please, this one. See, the capacitance of a PPC partially filled with the dielectric is there. No? So here what is there? Again I have told you here what was there? The charge was there. Which charge? Plus charge. No? Plus charge here sigma. And here which charge was there? Here the minus charge is there. How much? Minus sigma, and this is connected to the ground. Okay. So what is there students? E and E naught is the electric field in dielectric and in air. Then potential difference V between the plates is given by here. Okay, so again I am telling you, see here, no, see here students, see between the dielectric here, electric will be how much here? E, but in air here how much? E naught, here also how much? E naught. Okay, and let's take what is there? The distance between the plates is D, and the thickness of dielectric is how much? T. Okay, here potential how much? V, here potential how much? 0. That means again we are writing here, see, V equal to, first if we see air, so for air what will happen that here? E naught D minus T for air, because electric field is E naught and thickness of the air, this is D. Dielectric in a, how much thickness? T thickness here, see, this is the dielectric, Okay, so what will happen that here? D minus T plus again E into thickness of the dielectric T. So we can write here E naught D minus T plus ET. Now students, see this V equal to E naught D minus T plus, here what will happen that here? Electric field between the dielectric is given by here E naught by K into T. Okay, now students, let's see this, we can write here V equal to E naught, take here D minus T plus T by K. What is this? D minus T plus T by K. Next one, see, V equal to, what is E naught? E naught is students what? Sigma by epsilon naught. What is this? Sigma by epsilon naught here. Sigma by epsilon naught, and here what is this? D minus T plus T by K. Okay. What is sigma value? Sigma means Q by A. Okay. So see students, see, V equal to sigma how much here? See here please, again back side here, V equal to sigma by epsilon naught is there now. So sigma means Q by epsilon naught here. Now so see, Q by epsilon naught, and here sigma is Q by A, and here how much is there? See, D minus T plus T by K. Okay, students, so if I write here what is the Q by V, this Q by V will become here what? Just check out here, epsilon naught A by D minus T plus T by K. And what is Q by V? Potential. So it will become here C equal to epsilon naught A by D minus T plus T by K here. Okay, this is the capacitance when the dielectric is partially filled between the plates. Okay, after that what will happen that here? Remember that one thing here, if in case complete dielectric between plates, okay, complete dielectric between plates. So in this situation what will happen that here, when there is the complete dielectric between the plates, then what will happen that here, this T will become equal to D. Complete dielectric means what will happen that here, T will become equal to D. Okay, then what we can write here, we can write here C equal to epsilon naught A by D minus D plus D by K. Then what this will become here, it will become here C equal to this D and this D cancel, that means K epsilon naught A by D. And which formula we have got? We have got the formula C equal to Kc naught, as I have told you. Okay, and if in case question used to come, if we take one more here, question used to come like if instead of that dielectric metal is there, for metal of thickness T, for metal of thickness T, for metal of thickness T. So you know what will happen that, students? Here what will happen that, students? Here in this situation this capacitance will be how much here, epsilon naught A by D minus T plus T. For metal K how much? Infinite. That means here the capacitance will come here how much here, epsilon naught A by D minus T. Okay, just D minus T, because T by infinity how much here, 0. Okay, so this will be the students capacitance. Okay students, so what we have done, we have learned about the capacitance and all these things. Okay students, keep studying, keep going.